Yeah, how
Lots of
many
ARM cores.
cores are in the machines that you're
So we
using?
are using single CPU servers, and each CPU has 128 cores, and we are
128
utilizing those
cores.
cores. Yeah,
Amazing. Yeah, yeah. Yeah, just as a quick aside, this really is a tremendous showcase for high density core count, in a CPU. And of course ARM is really the only architecture that can support that. At least support it, shall we say, economically, and then in a green way without needing a power plant, to run the server. So
absolutely, absolutely. And so the audio encoding is part of what we do in CPU. The other part is that for some historical reasons, the signal that we get is at times still interlaced. So we have
interlaced.
to
Yeah,
deinterlace it. So
yeah.
deinterlacing and audio encoding is something that we rely on the
On the
CPU to do.
CPU. Yeah.
And that's a really good reason. So they're not just idling around; they're really doing some work at low power. So that's a very good combination in combination with the acceleration that we get from the
Yeah.
VPUs.
Yeah, and it's great because when you're offloading all that video encoding and scaling, essentially everything needed for the video portion of transcoding, now you effectively free up, not 100% of the CPU, but upwards of 80%, even 85% of the CPU is just sitting there idle.
Exactly.
So if you have a big powerful machine with a lot of cores, like an Ampere-based server that you're using, it's perfect. It's perfect for the application.
Yeah, and we are just on the edge of booking or of ordering some of the new supermicro servers with the new Ampere CPUs that have even more cores,
Yeah.
because we have a real need for that. And in combination, we would have needed many more servers if we didn't have the ASIC acceleration of the NETINT VPUs. That's a really game changer for us. Yeah, and this is the whole workflow. So we have an integration into some existing systems, so we get event metadata about which sessions are going to be played. We have a content management system that we built, especially here. That content management system receives these metadata elements and then controls two parts. One is a part of on-prem encoders, and we call them AVPUs, Audio Video Processing Unit. The NETINT VPUs are part of that. So we have a couple of them on-prem in Brussels and Strasbourg, and they have SCI capture cards on board so that we can get the signals. They push a single bitrate stream via SRT over to some cloud transcoders that we also operate ourselves, so it's hardware that we control. And then we have these two working hand in hand. The on-prem encoders feed a 24/7 ring buffer so that nothing is lost. They feed an internal multicast network that the European Parliament is operating, while the cloud transcoders transcode to the ABR sets and then push to the CDN, to the social media streams, and provide clipping and email functionality.